Welcome to my presentation. Assalamu alaikum, sir. I am Mubashir Ahmed Nasrullah. Uh, First of all, thanks my teacher to give me the opportunity to present my topic. Now, I would like to my presentation. I would like to start my presentation, and my presentation topic is current mirror circuit and current steering circuit. Okay. So this is the content of my of this presentation, and here also the content. So first of all, current mirror circuit. Okay. So what is the current mirror circuit? Current mirror circuit actually is a widely popular technique for monolithic IC design. In this technique, the circuit is designed in such a way that it copies the current through one active device to another active device with the current control feature. In this, the current is flowing through one device can be copied into another device but in inverting form. If the current of the first device is changed, the mirrored current output of the other device will also change. So, by controlling the current in one device, the current in another device can also be controlled. Thus, the current mirror circuit is often referred to a current controlled current source or CCCS. Uh, this is the also current mirror circuit, and now here I explain about characteristics and dependency of current mirror circuit. So this is the current first of all current transfer ratio. Okay. Actually, current transfer ratio, a circuit mirror circuit, a current mirror circuit mirror or copy the input current of one active device to the other active device's output. A current mirror circuit mirror or copy the input current of one active device to the other active device output. Okay. An ideal current mirror circuit is an ideal current amplifier with the inverting configuration that can reverse the current direction. Therefore, for an ideal current amplifier, the current transfer ratio is an important parameter. And then we see that from the slide, AC output resistance. Okay, so AC output resistance has a voltage current relationship as per the Ohm's law. Thus, AC output resistance plays a major role in the stability of output current with respect to voltage changes. And this is the voltage drop. Actually, a minimum voltage is required to keep the transistor in active mode, so the minimum voltage depends on the transistor specification. A proper working mirror circuit has a low voltage drop across the output. A voltage range in which a current mirror circuit can work is called compliance range, and the minimum to maximum supported voltage in this compliances range is called as compliance voltage. A minimum voltage is required to keep the transistor in active mode. So the minimum voltage depends on the transistor specifications. Okay, here current mirror circuit using BJT. What is BJT? BJT means bipolar junction transistors. Okay. So, bipolar junction transistors are widely used for current mirroring. The first trick to use a bipolar junction transistor as a current mirror circuit is to construct an exponential voltage to current converter using the transistor. This is done by providing voltage across the base emitter junction of the BJT, and the collector current is taken as an output. In this voltage to current converter configuration, simple negative feedback across the transistor converted the voltage to current converter properties to an opposite logarithmic current to voltage converter. Generally, the negative feedback is done by joining the base and the collector to the transistor. Now current mirror circuit using transistor. Okay. So this diode can be easily changed using a transistor which is same as the other counterpart. Uh, in this circuit, two transistors are shown which are used to create the current uh, mirroring circuit. Transistor T1 and T2 need to be the same counterpart. Also, the two transistors should be placed close to each other for equal heat transfer. If we see the circuit carefully, the base emitter of two transistors T1 and T2 are in parallel with each other. Therefore, the two transistors have the same current. So, the best way to determine the output current is to add up the node current, where the IREF is following. Okay, um, IREF is equals to okay, so this is the current mirror circuit using transistor. This also IRF is equals to IC plus IB plus IB, and then IREF is equals to IC plus 2 IB, IREF equals to IC plus 2 IB, and IREF equals to IC plus 2 into IC divided by beta. IREF is equals to IC 1 plus 2 by beta. Current mirror technique using MOSFET. This is slide about the current mirror technique using MOSFET. Okay, so consider the above current mirror circuit using MOSFET. The MOSFET transistor actually M1 is in the saturation region as the VDS less than is equals to VGS. Okay, for the case of MOSFET M2, it will also remain in saturation mode as long as the output voltage is greater than the saturation voltage. Therefore, the input current across the M1 will control directly the output current of M2. Actually, MOSFET device function like this. The drain current reflects the function of the gate to source and drain to gate voltage. If the drain to gate voltage VDG is 0 for the MOSFET M1, the drain current of M1 will be therefore F VGS 0 equals to IN. Thus, IN sets the value of VGS. The same gate to source voltage is reflected across the M2. So, if the M2 biased using 0, VDG and provided transistors transistors M1 and M2 share identical properties and exact matching. Okay, then the function can be expressed here from the slide. We see that id equals to f into vgs vds vdg. Id is equals to half capi w by l into vgs minus vth whole square into 1 plus lambda vds, and is equals to uh, id is equals to half capi into w by l into vgs minus vth whole square into 1 plus lambda, and then vdg plus vgs. Now I am explain about applications of current mirror circuit. Okay, there are wide, first of all, there are wide applications from current mirror circuit in the field of integrated circuit manufacturing. The reference current source is created using the current mirror circuit. And by using this technique, multiple reference points can be created from a single source. Hence, changing one reference point also change the current source across different parts of the circuit. And now, this is the current steering circuit. Okay, so what is the current steering circuit? Actually, current steering is basically switching current between two sides of additional pair with current. In other words, the current source current is steered from one side to the other side of the differential pair. Actually, the current steering is also this invention relates to current steering circuits that provide a predetermined circuit to one of two differential output terminals in response to complementary input signals, such as for use in a digital to analog converter. Here we see that BJT current steering circuit. Actually, uh, this BJT current steering circuit generates bias currents for different amplifier stages in an IC. DC reference current IREF. IREF is equals to VCC plus VEE minus VER RI minus VBE2. Sufficiently high beta case neglected I beta and neglected early effect. And then most current steering circuit actually here that we see that from the slide, IREF by Q1 and R. Q1, Q2 and Q3 Q1, Q2 and Q3 is two output current mirror. Okay, I2 is equals to IREF W by L 2 divided by W by L, and then I3 is equals to REF W by L3 divided by W by L1. Okay, saturation region at Q2 and Q3, VD2 VD3 greater than is equals to minus VSS plus VGS I minus Vm. VD2 VD3 greater than is equals to minus VSS plus VOV I. Drains of Q2 and Q3 must remain higher than minus VE minus VSS by at least the overdrive voltage. So here we see that from the slide, application of current steering circuit. Here current steering circuit actually Circuits are the basic building blocks of certain types of digital to analog converters used in a wide range of applications, such as digital radio transmit signal chains, test equipment, simulus synthesis, wireline data transmission, and so on. In these applications, a critical DSC specification is the uh, spurious free dynamic range, which is directly determined by the amount of undesired distortion unavoidably added to the generated output signal. Okay, now this is the conclusion part of my presentation. We see that here the from the slide, current mirrors are awesome and dart simple, and they they allow to distribute a fixed current for use as reference across any number of subsidiary circuit and change them all by changing one. Current mirror finds extremely useful in differential amplifier and operational amplifier. The differential amplifier and the output buffer are both driven by a current mirror. In the telecommunication applications, high performance digital to analog converters are used more for the wireless local area network. In practice, for wireless communication, a current steering DSC is suitable because of its high sample rate, efficiency of driving resistive loads, and also due to low power consumption. In the telecommunication applications, high performance digital to analog converters are used more for the wireless local area networks. In practice, for wireless communication, a current steering DSC is suitable because of its high sample rate, efficiency of driving resistive loads, and also due to low power consumption. That's all my presentation. Thank you.